You know that perfect mirror-like shine you see on everything from a classic car to maybe even your kitchen faucet? Well, that's chrome, and it's one of the most important industrial finishes in the entire world. But behind that incredible gleam, there's a story that's a whole lot more complicated. All right, let's get into it.
I mean, we all know this look, right? We love it. Chrome pretty much became famous for giving cars and motorcycles that bright, reflective look that just screams style. It really defined a whole era of design, becoming a symbol of both beauty and durability.
But it's not just for show. Not at all. This is where chrome gets serious. What's known as hard chrome is an absolute workhorse. We're talking about coatings on things like hydraulic cylinders, machine tools, and molds, things that need to be incredibly resistant to wear and tear. This stuff extends their life like you wouldn't believe.
And here's the turn. The very process that creates this amazing, super strong finish, it comes with a hidden cost. A really dangerous one, actually. A cost that impacts our health and the environment in a big way. So to really understand the problem, we first have to get a handle on the appeal. I mean, why did chrome become so essential to begin with? It's a journey that takes us from pure decoration all the way to critical, can't-live-without-it function. The history here is actually fascinating. Back in the early 20th century, it was all about that shine, right? Making things look good. But by the middle of the century, engineers perfected hard chrome for heavy industry. Then the processes got more and more precise. And today, it's so high-tech we're using it in aerospace landing gear, tiny biomedical implants, and even on 3D printed parts. It's come a long, long way. And because of that, it's pretty much everywhere. Seriously, you'll find it in the car you drive, the plane you fly in, and heavy machinery that builds our world, and even in tiny, precise implants used in medicine. Chrome is this hidden but absolutely essential part of modern life.
Okay, so how in the world do you create a surface that's this strong and this beautiful at the same time? Well, the answer is in a process called electroplating, and you can basically think of it as a highly controlled, super-powered chemical bath.
The whole thing is a really cool piece of chemistry. First, the part you want to coat has to be perfectly, absolutely clean, no exceptions. Then, it gets dunked into a solution of chromic acid. You run an electric current through that bath, and here's the magic. It causes chromium ions to bond to the part's surface, literally atom by atom, building up this perfectly uniform, ultra-hard layer. So just how hard are we talking? Well, the number is pretty wild. Over 800 on the Vickers hardness scale. Now, to put that in perspective, that's harder than most hardened tool steels. It's why it can take so much abuse in factories and machines. It is incredibly resistant to scratches and wear. So you've got this incredible combination of benefits that made chrome the absolute gold standard. You get the extreme hardness, that amazing resistance to wear and rust, and a super slick, low-friction surface, all wrapped up in that beautiful, shiny finish. It's the total package. But remember that chemical bath we just talked about? Well, the key ingredient in that traditional process is also its greatest weakness. And this is where the story takes a really dark turn. Right? We have a super hard, corrosion-resistant, beautiful finish. It sounds perfect. So what exactly is the problem here? The problem has a name, hexavalent chromium, sometimes called chromium-6. This is the stuff that's in that electroplating bath, and it is incredibly dangerous. It is a well-known carcinogen, it's highly toxic to the workers who handle it, and it's a serious environmental pollutant. And this is the fundamental dilemma of chrome. It's a two-sided coin. On one side, you have all the amazing properties of the finished product, the hardness, the shine, but on the other, you have the severe risks of the process itself, a major cancer risk for workers, long-term contamination of soil and water, and because of that, governments around the world are putting in super strict regulations to ban it. And we're not talking about a minor risk here. This quote from the research makes it painfully clear. Even inside facilities with all the proper safety controls, the chemical mist that's created during plating poses a severe health threat to the people working there every single day. So because of all these dangers, the entire industry is in a race to find a better way, a race to create coatings that can perform just as well as chrome, but, without the toxic legacy. And the good news is there are a lot of contenders in this race. Scientists are developing all kinds of alternatives that get similar results through totally different, much safer chemistry. Take physical vapor deposition, or PVD. That applies a coating inside a vacuum, which means you avoid the toxic liquid bath completely. The goal for all of them is the same, get the performance, but without the poison.
The objective here is really simple to see. You want to keep this performance bar way, way up high, but at the same time, you want to slam that toxicity bar all the way down to the floor, basically to zero. It's all about decoupling that great performance from that terrible danger. So, ultimately, this whole thing comes down to finding a new kind of balance. The next generation of surface finishes has to do it all. It has to look great, it has to perform under extreme stress, and it has to be safe for people and for the planet. That is a huge technological challenge.
And that leaves us with the big question, doesn't it? We fell in love with chrome for its incredible strength and its brilliant shine, but now we know the true cost. So can innovation actually deliver a future where we can have all the benefits of this incredible material without having to pay that awful toxic price? The search is on.